Hi class, this video is on polynomial and rational inequalities, so let's get started. Okay, say we have this polynomial and we want to know where this product is greater than 0. So the way I like to do this is I just draw a number line and we basically have here's a -2, that's when this one's 0. Here's a 4, that's when this one's 0, and those are the points of inflection. So x plus 2 is, if it's less than -2, it's negative in here, it's 0 right at here, and then it's positive in this region. In other words, if I stick -2 in for x minus 2 is 0. If I put -3 in for that, -3 plus 2 is a -1, so it's negative. And anywhere in this region, if I put a 4 in there, 4 plus 2 is 6, it's positive. And we can do the same thing for x minus 4. At 4, it's 0. Anywhere below 4, like say 3 minus 4 will be negative, so it's negative in this entire region. And anything above 4, say 5 minus 4 is 1, it's positive everywhere out here. Okay, now the product, negative times negative is a positive. Right, this times this, the product is positive there, it's 0 here, it's negative in this region. Now we have a positive times a negative. 0 times a positive is 0, and then it's positive in this region. Okay, so that's our product, and when is it greater than 0? In this region and in this region. So we have from minus infinity, and it has to be strictly greater than 0. So up to -2, but not including -2, it's 0 there. Union with, well, at 4 it's 0, so we don't include 0. We don't include 4. All the way out to infinity. So this region, open circle here, everything out this way. An open circle here, the points not included, everything out this way, is in fact the points that satisfy this equation. Okay, let's take another one. Say we have something like x squared minus 4x plus 3, and this time it's less than or equal to 0. Okay, well, we just have to factor this. How does this factor? Well, we got an x minus 3 times an x minus 1, right, is less than or equal to 0. So what points work for that? And you can see we got x squared minus an x minus 3x and then plus 3, so it works. Okay, so we do the same thing. We draw a number line as best we can. And we draw like we write x minus 3 here and x minus 1 here. That's 0 at 3, so we'll just kind of arbitrarily put a 3 here. And this is 0 at 1. We'll call this, say we'll call this 0. This is 1. Okay, so x minus 3 at 3 is 0. Anything above it is positive. And anything below it, it's all negative in this region. X minus 1 is 0 here. It's positive in these regions and negative in this region. Okay, if we multiply them together, negative times a negative is positive here. So we have x minus 3 times x minus 1, multiplying that, positive, positive, positive. Okay, it's 0 here because this one's 0. Then a negative times a positive is negative, negative, negative. 0 times a positive is 0, and then positive times a positive is positives. We want to know the region where it's less than or equal to 0. So it's right in this region here. So this point included, so we make it a solid point. Okay, solid point. And everywhere in between. So there it is graphically. To write it in interval notation, we go from 1 to 3, and it's with brackets indicating that 3 is included. So a parenthesis means a point's not included. And a bracket means that it's included. Okay. All right. Let's do another example like that. If we are at x squared plus x minus 6, and that's greater than 0. So we just factor this again. That's going to be x. Let's see. The factors of this, 3 times 2, so x plus 3 times x minus 2 does it. And that's strictly greater than 0. So same thing, we draw our number line. This program doesn't let me draw it so straight, but you get the idea. We had x plus 3 and x minus 2, and then the product, x plus 3. Okay, this one's 0 at minus 3, so we have a 0 here. This one's 0 at 2, so I'll put a 2 here, and that's a 0. Any point more negative than minus 3, say minus 5. Minus 5 plus 3 is negative, so it's going to be negative anywhere in here. Any point greater than minus 3, say minus 2. Minus 2 plus 3 is 1, so it's positive, and certainly like 2 plus 3 is 5, positive. So it's positive in all these regions here. This one, it's 0 at 2. But any point less than 2, it's going to be negative. And any point greater than 2 will be positive. If it's 5, 5 minus 2 is 3, it's positive. Then the product, negative times negative, it's negative, negative, negative 0 right there. I mean, negative times negative is positive. No, it's positive, 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 0. And then we have positive times a negative, so we have negative, 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 negative. 0 times positive is 0, and then positive times positive is 0 is positives. And we want it to be greater than 0. So again, we have the points minus infinity. We always use parentheses for infinity because you can't contain it. All the way up to minus 3. And this one's a parenthesis since it's not part of it. Union with parenthesis 2 to infinity. So there it is, graphically, open circle, not included, this one. And it all depends on whether it's included or not, whether you have an equal sign here or not. And not included, and everything out here. So there's that one. Okay, we can do the same for rational inequalities, so very similar. And say this one is greater than or equal to 0. Okay, so we draw our number line. All right, and we write down x minus 4. We write down x plus 3. And then the quotient, x minus 4 divided by x plus 3. Right? So x minus 4 is 0 at 4. So we got a 0 here. So negative, 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 anything below positive, 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 positive. X minus 3 at 3, at minus 3 is 0. So it's negative, 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 positive, positive, everywhere above minus 3. So the quotient is just like the product. Right? A negative divided by a negative is positive. So it's positive all in this region. Now, one slight difference, if I put minus 3 in here, this is 0, but I can't divide by 0, so I call it undefined with a U. Negative times a positive is a negative, so it's negative in this region. 0, that's on the numerator, times a positive is 0. And positive times a positive is positive. Okay. So now we have, when is it positive or equal to 0, we have this region and this region. So it never can contain negative infinity, so negative infinity to up to minus 3. But at minus 3, it's undefined, so we use a parenthesis. Okay, so union with a bracket for it being included, we go to 4 and all the way out to infinity. So there it is. So a solid circle here and everything out that way. Open circle here and everything out this way. So there it is graphically and in interval notation. Okay, last one. We have x minus 5 over x minus 2. And let's say that's strictly less than 0. Then, again, we write our number line. Okay, we have x minus 5. And we have x minus 2. Now that's 0 at 5, so I'll just say this is 5 here. This one's 0 at 2, so I'll just call it 2 here. Okay, and then this one's negative here. 0 and positive. And this one's 0 here, positive over here, and negative throughout all this region. Now the product then, or the division, is so x minus 5 divided by x minus 2, right? Negative divided by a negative is positive, so positive here. 0 is on the denominator, so undefined. And it's negative here. And it's 0 right here, and positives here. We want it to be less than 0. When it's less than 0, we want to, well, if it's two products, we get something here, but okay. So undefined isn't included, so it goes from 2 to 5. And we want it less than 0, so that's not included as well. So from 2 to 5, and graphically, we have it like this. This region right in here. Okay. Okay, well, I hope this video helped you learn the material, that you enjoyed the video, and that you enjoy your learning. Cheers.